Thank you. Okay, everything works. Hello, my name is Spacek, and I'm working with a group. We are private research laboratory Firebird Biomolecular Sciences. That is me, Jan Spacek, students Spencer Cady, Gage Owens, and Daisy Sharma, and PI chemist Stephen Benner. And we had Paul Rimmer contributing to the results I will be presenting today. The results we are showing today are made for Morningstar missions. So now the Morningstar mission, they were previously known as a cloud life, Venus life cloud something. Now it's a Morningstar renamed. So it's led by Sarah Seeger, Janusz Petkovsky, Pete Cooper, and we are collaborating with Rocket Lab and many more in the room. We have David Greenspoon, Chris Carr, and so just advertising tomorrow for Chris's talk. This is the mission. We will fly in 2025 to look for fluorescence in the particles, and we will be looking for why the Venus is yellow, right? So today I'm going to convince you that Venus is yellow because the organics in the clouds of Venus. 2 years ago, I've written this paper where most of this will be resubmitted to peer-reviewed journal. The part describing why organic carbon cycle was not discussed before. This was a dispute between pseudoscientists and Carl Sagan. That will remain only there, I think. So how the originally presented carbon cycle look like? That you have some sort of organic carbon, simple molecules that if you heat them up in a sulfuric acid, they make larger molecules, which are changing the colors of the droplets. As you dry the droplets at the bottom of the cloud, the organic molecules coalesce to larger molecules, turning into particles which fall out of the cloud. Below the cloud, they are reacting with carbon dioxide and are gasified to form carbon monoxide, which is reduced on the cloud tops back to formaldehyde. So since the publication of this original hypothesis, we made some changes. So the reduction, according to Paul Rimmer, is not through using water, but it's photochemically reduced through hydrogen generated from hydrogen H2S. I'm not so sure about the volatile hydrocarbons in the upper haze, but what we have very well described now is the reaction between carbon monoxide, formaldehyde, and water forming glycolic acid. That's the first carbon-carbon bond. And we discovered new protonation of carbon monoxide. I'm not so sure about the methane from volcanism, and I learned that boudoir reaction is spelled with capital B. So just a few highlights. Sulfuric acid has a very high affinity towards volatile organics. So even if you have very small amounts of photochemically generated organics at the cloud tops, the sulfuric acid will accumulate them very efficiently. Organics are not destroyed in a sulfuric acid. They are actually driven towards making larger and larger molecules, which are UV vis absorbent, as I'll show you later. And in industry, these like mixtures of organics within sulfuric acid were named red oil, and I adopted this name for my organic carbon cycle. And as I mentioned before, below the clouds, the particles which must be falling from the cloud are gasified through Boudouard reaction, reaction with carbon dioxide to make two molecules of carbon monoxide. To give you some intuition about this, if you put some organic material into sulfuric acid, it starts usually as a clear solution, but over time, it turns into dark, up to black solutions. These solutions are fluorescent. This is some sample in NMR tube, and they are like very brightly fluorescent. If you have it concentrated there, it looks like a glow stick. Usually it's a blue-green fluorescence. Sometimes you have like nice yellow or white fluorescence. You can map out the fluorescent profile as a 3 fluorescent spectrum, which means excitation, emission, and intensity. And here you can see that we have fluorescence with emission around 370 nanometers. So that would be plotted somewhere around here. And this diagram shows maximums of different fluorescent materials under different conditions. We used these maxima to tune the laser we will be using in the Rocket Lab mission in 2025 to look for organics in the Venus clouds. So the project I'm working on is guiding this mission design. If you heat up, if you continue heating up this timeline, if you continue to heat it up, you form dark or black particles, which are suspended in sulfuric acid. I suspect that they are with multiple charges as polycations, I guess with positive charge on carbon. And when you dissolve it in water, basically pour this sulfuric acid solution into water, they lose the charge and precipitate. So I decided then to isolate it and dry it. And most of the particles were starting from formaldehyde were turned into this black carbon, which with a quite good yield. So I just showed you chemistry, which is quite interesting, but is organic chemistry in the Venusian clouds? Well, certainly, because organic carbon is falling to Venus clouds, right? So if you put Murchison meteorite, which contains organic, it dissolves in sulfuric acid, turns into the red oil, which is then fluorescent. But the question is, this might be insignificant because there might not be enough meteorite to affect the microphysics of Venus. But the question is, are organics produced locally in the Venus atmosphere? And the answer is also certainly yes. So technically, protonated carbon monoxide, it's organics, right? Because we have definition of organics as molecules with a CH bond. And we discovered that if you have above 70% or 75% sulfuric acid, the carbon monoxide is protonated in it, which is very interesting. Because protonated carbon monoxide is accumulated in the sulfuric acid, so you can sequestrate from the atmosphere. So the carbon monoxide is a nucleophile in this resonance structure, meaning it has negative charge. And some molecules have been found to be quite stable in sulfuric acid, but that's only as long as you don't have any carbon monoxide which can attack it. Here is clear evidence that we have this protonation. So if you put formic acid into sulfuric acid, that's the blue line. You can see the original formic acid is turning into protonated carbon monoxide. And after 13 days in the room temperature, we have nice 3 peaks due to deuterium resonance and carbon monoxide signal. Now, Paul Riemer provided us with a photochemical prediction. So we have even more reduced species than formic acid in the clouds of Venus. And they are produced at very low concentration, 1 to 50 parts per trillion of formaldehyde. But because of the very high affinity of the sulfuric acid to organics, it just pulls them from the air and equilibrates at 0.14 millimolar concentration of formaldehyde, which is enough to be significant for the absorption. So we decided to map out the first reactions happening in the from formaldehyde. And it turns out when you put formaldehyde alone in a sulfuric acid, it disproportionate, meaning it's both is oxidized and reduced. It's oxidized to formic acid, which is then dehydrated to protonated carbon monoxide, and it's reduced towards methanol, which makes methyl sulfate predominantly with sulfuric acid. But over time, after 20 minutes, you can see start of a glycolic acid appearing and glycolic acid sulfate ester. So that's formation of new carbon-carbon bond happening within minutes after addition in 60 degrees Celsius in this case. This experiment is more relevant for Venus atmosphere. We put formaldehyde, dissolved formaldehyde in sulfuric acid, and kept it overnight under CO atmosphere, carbon monoxide, and overnight it reacted fully to produce semi-labeled glycolic acid. So this is clear evidence that I should move faster. Okay, so this is glycolic acid. I think this is the first species. Very important part is notice that we have reaction with carbon monoxide and water, and the UV absorber is anti-correlated with carbon monoxide and water, which suggests that the Koch absorption, Koch reaction, protonation of carbon, addition of carbon monoxide, addition of water is happening and generated the UV absorber. So the spectrum of the red oil or the UV absorber can be tuned. So if you give me if you give me a spectrum I should match, I can cook you UV absorber under Venus conditions. Right, and I'll skip over these. Just say that what we discussed before, these can be accumulated through uplifting because as things get more absorbing, it's uplifted to the upper cloud and stay there longer. And we have also a selection for single particles through negative photophoresis. So I believe that there is red oil and organic carbon cycle in the Venus atmosphere. I'm not sure how to quantify it precisely, but in 2025 we will send the probe to detect it. So thank you for your attention.